Welcome to the deep dive into modern cars, where we're exploring the mind-blowing tech that's been quietly revolutionizing the drive. It's like, each component is a small miracle. Am I right?
Absolutely. The integration of sensors, data systems, and vehicle dynamics has totally redefined what a car can do. Yep.
Right. And starting with sensors, cars today basically see the world way better than we ever did. With their high-resolution imaging, night vision, and thermal capabilities. It's like they're operating with superhuman vision.
Exactly. And it's fascinating how we've moved from the early trio of cameras, radar, and LiDAR to these next-gen solid-state LiDAR systems. You know, the kind without any moving parts.
Oh, exactly. As opposed to those spinning, mechanical LiDAR assemblies. Mechanical ones are cool, but they're bulky, expensive, and kind of fragile. With solid state, you get a smaller, robust, and cost-effective solution. And that means more sensors per car.
Yeah. It's like having a 360-degree set of eyes that never blink, right? Better all-around safety and enhanced data capture, especially in poor conditions like heavy rain or fog.
Yep, and that brings us neatly to data acquisition, or DAQ. It's the nervous system of the car, collecting and processing the torrent of data streaming from every sensor. Imagine it as, turning raw chaos into actionable intelligence.
For sure. Modern DAQ systems are under immense pressure, especially with electric vehicles and autonomous driving systems generating, massive amounts of data. Every microsecond counts in these situations.
The way DAQ is used is pretty impressive. Take the example of monitoring EV battery performance. Continuous checks on voltage and temperature help optimize safety and range. It's kind of like having a personal doctor for your battery.
That's a neat analogy. And then you have companies like Keysight and Doosoft, whose systems ensure that even the tiniest component, like say a MOSFET, is performing exactly as it should, right?
Definitely. MOSFETs may be tiny, but they're critical, acting like microscopic switches. The DAQ systems deliver high-speed, perfectly synchronized measurements, which are essential for reliability and safety.
I have to say, though, while DAQ is amazing, sometimes it feels like we're pouring so much data in that we risk overloading the system. But the next-gen instruments seem to handle it pretty well.
True, there's always the balance challenge, too much data, and you need equally powerful processing. Now, shifting gears, literally, let's talk steering and handling. These aspects seem deceptively simple, yet they're engineered with such finesse.
Oh, absolutely. Even the steering geometry, like kingpin inclination, really affects how a car feels on the road. It's responsible for that self-centering action after a turn, so you get stability and responsiveness.
Exactly, it's like, the car's personality emerges from these subtle design choices. And now power steering involves sensors too, like Hall effect sensors, which measure the exact force and angle applied by the driver.
Right. And this sensor data doesn't just go to making parking easier. It also feeds into systems like lane keeping assist. It's like the car's brain is constantly fine-tuning these inputs to make sure everything works seamlessly.
Speaking of fine-tuning, vehicle dynamics are where the magic happens. When you think about it, the overall behavior of the car, from acceleration and braking to cornering, is an orchestration of countless variables.
Yeah, vehicle dynamics involve everything. They account for forward motion, lateral shifts, and even vertical movements. It's an engineered ballet, really.
Totally, and part of that ballet is understanding how tires work. You have slip angle, which is the difference between the direction the tire is pointing and where it actually goes, and slip ratio, which plays a critical role, especially in systems like ABS.
Right. ABS ensures wheels don't lock up during braking. It constantly adjusts brake pressure to keep that slip ratio in the ideal range. Without these fine measurements, the car might just spin out of control in emergencies.
Exactly. It's a delicate balancing act. The tire models these days, like those high-frequency models, are incredibly sophisticated. They capture deformations and slips in fractions of a second, setting the stage for precise braking.
I mean, without this, emergency braking could be a chaotic mess. But I do wonder, aren't these models sometimes over-engineered? I mean, could a simpler model work in everyday scenarios?
That's a good point. There's a trade-off between accuracy and efficiency. But for high-stakes situations, like on wet or icy roads, the extra complexity is